Okay, let's look at this now. Come on. Okay. Say that we call that the moment of force about any point A is F into dA, where dA is the perpendicular distance from the point to the force line. We've already covered this. This concept can be extended to find the moment of force about an axis. So I've already explained you. Let's say, come on, where is it? You've got the moment being applied here. You can find this component here and here. So if you after this component knowing the angle or the slope, you can get easily do that. So you can find this. So in the figure above, the moment about the y-axis would be this. However, this calculation is not always trivial, and vector analysis may be preferable. So what it's saying here basically is that if you got a moment being applied at any one point, you can find its component and on any of the axes here. I want this one, or I can find the effect of this on this, sorry, on this axis here. So that would be this component and this component. So I can define this component out. So that's what it says here. Okay, vector analysis. So our goal is to find the moment of F, that's basically tendency rotation, about the axis A dash. So basically, in simple words, what we're looking at is basically you've got the force being here, and this force is creating a moment of which the axis is here. This force is creating this moment. So this force is creating this moment. I want to find the moment, the component of this along this axis here. So that is this axis here. So in simple words, that's MA. So how to do that? So the first, compute the moment of F about any arbitrary point O that lies on the axis using the cross product. So how are we going to find the moment? In the previous example, it was relatively easy to visualize. You can really visualize it very easily. It is easy. You can do that. But as you get into the real world, it becomes more complicated. So we've got a methodology to find a moment at any axis. So how are we going to do this? So it says here, first compute the moment F about any arbitrary point O that lies on the A axis using the cross product. So in simple words, you've got this force and you have to find a moment about a point on this line. So I can find a point here, or I can even find a point here, or I can even find a point here. So if I want to find moment at point N, then this is my position vector R. If I want to find moment at point M, then this is the position vector R. Sorry, R. So in simple way, it says here, the very first thing you need to do is to compute the moment F about any point O that lies on this axis using the cross product. So that's the very first thing you're going to do. Now find the component of M naught along the axis AA using the dot product. Then. So basically what it says here that once you found the moment, once you found the moment, sorry, where is it? Once you found the moment, let's say m naught. M naught is the moment at point O, which lies on my A dash axis. This is my A dash axis, remember. So O lies on A dash axis. So I want first thing to do is to find moment at point O. and then you do the dot product, which is basically m naught. Mo is basically the moment that you found at any point on the axis, and a is the unit vector of this axis here. This is given here. That's the unit vector. So, in simple words, what it says here, excuse me, excuse me. What it says here, if you got a force being applied and it creates a moment, and you want to find the moment, the component of the moment on any axis, the very first thing you need to do is to find the moment at any point on the axis. So I can use r, this r, I can use this r, I can use this r, or even I can use this r. So I will say this A, B, C, D. So I can find M A or M B or M C or M D. I just need to find the moment on any point on the axis. Once I found the moment at that on the axis, then I need to find the unit vector of the axis, and once I've got that, all I have to do is MA dot UA or MB dot UA or MC dot UA and so on. So that will give me the component of the moment along the unit vector direction. So in simple words, is given here. This is what you have to do. Simple as that. So what it says here is MA is the moment component of moment acting along this axis, which is basically the unit vector dot m naught, and that's where m naught is basically a vector. You can basically, that's r cross f. uh, uh, No, I have made a mistake here. I made a mistake because look, MA, and this is M naught dot UA, and I've written here M dot UA dot M naught, because remember you just mentioned to me that R cross F is not equal to F cross R. So I
सर
made a
ये तो
mistake
सेम नहीं
here.
होगा, ये तो
Dot
डॉट
product is
प्रोडक्ट था.
considered, sir.
Yes, it's a dot product. This law applies to cross product only. So for dot product, it doesn't matter. So m dot dash UA is equal to UA dot MO. So that's right. So is this clear how we're going to find the component of moment on any axis?
Yes sir.
Yes, sir. Okay, so let me, I've got it here. Yes. So remember, let me just summarize, it's very important. If there's a force being applied, where like shows here, and I want to find the moment being created at any axis, uh, 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 the moment created on, sorry, let me say it again. Uh, that's the force being applied. I want to find the moment created by this force on any axis, the effect of it on any axis. The very first thing I need to do is to find a moment at any point on that line, on any point on that line, and then have a dot product with the unit vector of that axis. Clear?
Yes, sir.
Okay. Okay.